power of I. Now, before I start with these higher degree i's, I'm going to talk about just where I comes into play and why we have this specific variable to represent the square root of negative 1. So just a quick review here. The square root of 9, as you probably know, is 3. So 3 times 3 is, square root of 9 is 3. So 3 times 3 is 9. But also, if I were to say, what's the square root of negative 9? Square root of negative 9. Well, in that particular case, there's not a way to create the square root of negative 9 because we'd have negative 3 times 3. So in this particular case, if we were to look at this, we'd have the square root of 9 and the square root of negative 1. And it would be just considered 3, and the square root of negative 1 is represented by the variable I. So the square root of negative 9 would be 3i. This came into play when we are solving quadratics where the discriminant is negative, in which we talk about how that would result in two imaginary solutions. So big picture stuff here, we're going to be in an additional video with this section. We're going to talk about complex numbers, in which we have a real part and an imaginary part. But before we get to that, let's consider this idea of just focusing on the powers of I. So what I've written here are pretty much the 4 different answers that could occur when you have higher degree or higher powered i's. So for example, we just covered what I equals. It equals the square root of negative 1. I squared equals negative 1. And then as we get to higher degrees, I to the third equals negative I. And why that is because if I break this down into I squared and I to the first, we know that I squared equals negative 1. So that would be negative 1 times I, or just simply negative I. If I had I to the fourth, I could break that down into I squared and I squared, because I squared times I squared would still equal I to the fourth. And then I squared, if we look at my chart over here, I squared equals negative 1 times negative 1 would equal just simply 1. So that's how we get these other type of powers here. Now, this I to the fourth is very important. This is kind of like our jumping off point to solve these higher degree or higher powered i's. So if I focus down here, if we look at this one here, we're looking for how many groups of 4 can we take out of I to the 25th, okay? So bear with me here. I'm going to, if you've already considered probably your answer here. So I have I to the fourth here, I to the fourth here, I to the fourth. If you're thinking there are 6 groups, you are correct. Okay? So if I take out I to the fourth times I to the fourth times I to the fourth, I gotta put one more on here. So that would be 24 i's grouped up right there. How many would be left over? Well, we'd have 1 I left over. Now, why I to the fourth is so important is because it equals 1. And 1 being a multiplicative identity, meaning no matter what I multiply 1 by, it remains the same. 1 times anything is still the same thing. Then we end up with just the remainder after taking out all these groups of 4. So in this particular case, all my groups of 4 turn into 1. So it would be 1 times 1 times 1 times 1 times I. So the remainder was a single I after taking out 24 groups of 4, or sorry, 6 groups of 4, which resulted in 24. And so my answer to this question is just simply I. All right. So bear with me here. I'm not gonna draw that out again, but just check out this next one. If you can think about it, I to the 30th. How many groups of 4 can I take out of that? If you said 28, okay, 28 is a factor of, or sorry, a multiple of 4. And so, if you think about it, that would be I to the fourth times I to the fourth times I to the fourth times I to the fourth. And then we have 7 of those. And what would be left over? I'm going to draw this one a little shorthand here. We'd have 2 left over. So I took out all the possible groups of 4, which in this case there are 7. 7 times 4 is 28. So this I to the 28th just simply equals 1. And the leftover is I squared, which I squared equals negative 1. So therefore, I to the 30th equals negative 1. My whole goal here is just to look at multiples of 4. All right? So let's take out this one. What's the closest multiple of 4 I can get to? In this particular case, it would be 44. Okay? 4 times 11 is 44. So if I write it out, let's see, I to the 44th, and then what would be left over? Well, 3 would be left over. I know that I to the 44th would be just 1 times I to the 3rd. So I look over at my chart here, I to the 3rd equals negative I. Okay? So all I'm trying to do is just take out as many groups of 4 as possible. And once I do that, I look at the remainder. The closest I can get to 47 without going over is 44. The remainder is 3. So then I just look at my power chart here, and it equals negative I. The last one looks like a crazy number to have here, but just think about it. I, in this particular case, 100 is a multiple of 4. And so, if you think about it, it would just equal 1. If I wrote out 25 groups of, I'm not going to try it, but you think about it here, if I wrote out 25 of these groups, it would equal 100. But at the end of the day, it's just 1 times 1 times 1 times 1, 25 times, so the answer would be 1. Okay, so in the nutshell, you're just going to have these 4 possible answers, okay? And when you take out as many groups of 4 as possible, you look at the remainder and look at the chart to see what it equals. So hopefully this video helped you. If not, just please come see me. It just takes multiple practices a little bit, but I thank you for your time and have a good rest of your day.